In this demonstration, I'll go over how to use the read command in a shell script. In Linux, the read command asks the user for input and stores it in a variable. After that, we can do whatever we wish with the value. Here on my Linux system, I'm in the scripts directory where I'm going to type vi space menu.sh. I'm going to create a brand new file, and it's going to be a shell script, and I'm calling it menu.sh. I'll press enter, and I'll press insert so that I can modify the contents of the file. So we can see that there's nothing here because it's a freshly created file. The first thing every script needs to start with is the shebang line. So I'll type #, exclamation mark, /bin, /bash, because this is a bash shell script. And I'm going to use the echo command, space, and in quotes, I'm going to have a heading that says menu. We're going to build a little menu system in our script. Then under that, I'll have echo again, and in quotes, I'll have /list logged on users. That's going to be our first menu item. Then I'll just have a blank line. So echo quote space quote. And what I want to do is ask the user for input. So then I'll use echo, please enter your choice. Then I'll use the read command, followed by a space, and the name of the variable in which I want to store what the user types in. I'm going to call this here menu choice. So my command then in the script is read space menu choice. And for now, we're just going to echo back what the user typed in. So I'll type echo space, you typed a, and then I'll put in $menu choice, because when you want to retrieve the value of a variable, you must precede it with a $. Now I'm going to press escape so I can go back to command mode, and I'll type :WQ for write and quit, so to close and save the file. And I'm going to type chmod space +x space menu.sh because it needs to be flagged as executable. Now if I type ./menu.sh to run my script, it has my menu where I see option 1 to list logged on users, and it says please enter your choice, and the cursor's waiting for me. So let's say I type in a 1 and I press enter. It then says you typed a 1. So the read command can be used to gather any type of information from the user, whether it's a number, a date and time value, a text string, anything at all. But normally we need to be very diligent in checking what they've typed in. We haven't done that yet, but we do know now how to use the read command. In this video, we learned how to use the Linux read command in a shell script. In this video, I'll demonstrate how to use logic statements, both at the command line and within a shell script. The first type of logic statement we'll take a look at is the if statement. We'll begin working by testing a condition at the command line. At the command line, I'm going to create a variable called age by typing age equals 30. So I've placed the value of 30 into my age variable. We'll verify this by typing echo space $age, and it returns 30. I'm going to test a condition here. I'm going to test the value of the age variable directly at the command line. So when you're testing conditions, you can place conditions within square brackets. But the key is to ensure that after your opening square bracket, you've got a space, and before your closing square bracket, you have a space. Within that, you can then put your condition. Here, I'm going to be testing $age and verifying whether it's, in my example, greater than 65. So for greater than, I'll type in -GT. The GT is for greater than, then a space, and then 65. Remember, you've got to have a space after the opening square bracket and before the closing square bracket. Otherwise, you'll get a syntax error. After the closing square bracket, I'll type in 2 ampersands, and then what I'm going to do is type in echo space and in quotes senior. What this means is that if both conditions are true, that's what the double ampersand means, then it will execute what is on the right-hand side, which is to echo the text senior. But if any one of these two things is not true, now the two things I'm referring to are the item to the left of the double ampersand operator and the item to the right. So if either one of them are not true, it will not echo back the word senior. So if I press enter, we don't get anything echoed back. That's because the age variable contains 30, which is not greater than 65. But why don't we change that? I'm going to type in age equals 66. We'll just type echo $age to verify that that's stuck, and it did. I'll use the up arrow key so we can test our condition on the command line again. And notice that this time it in fact does return the word senior because the age variable has a value that is greater than 65. But we can also work with conditional statements, an if statement within a script. So I'm going to type cat space menu.sh. This will show me the contents of an existing shell script. However, I could also use gedit to open the same file, the graphical editor. So I'll type gedit space menu.sh. Clearly, there are benefits to doing it this way if you have the graphical environment because things are color-coded when you're looking at a script. It makes it much easier to read. Here in this script, we're displaying a simple menu system using echo commands. And down below, we're using the read command to read in what the user selects as a number from our menu. We're reading that into a variable called menu choice. After which, we're using an if statement where we are testing the value of the menu choice variable to determine first if they've typed in a 1. If they've typed in a 1 to list logged on users, then we are clearing the screen and then executing the who command. Then we have an else if statement, which is spelled ELIF. And again, within square brackets, with a space after the opening square bracket, remember, and a space before the closing, we are next testing the menu choice variable for a value of 2. And if that is true, then it will list the Linux kernel version, it'll clear the screen, and it'll do that by issuing the uname-r command. Our if construct has an else, so what if the user did not press 1 or 2? That would fall under the else in our script, in which case there's just an exit statement. Our if statement gets terminated at the very end with fi, which is the word if spelled backwards. So we're going to run this script, it's called menu.sh, and test what happens when we press 1 and when we press 2. To execute the script, which is in the current directory, I would type // and then its name, which is menu.sh. Here's our menu. I'm going to press number 1 to list logged in users, and when I do that, it returns a list of logged in users. So in other words, it's executed the who command. Let's run the script again, and this time we'll press a number 2, which should list the Linux kernel version. And indeed, it does just that. We'll run the script again and we'll press anything other than a 1 or 2. So for example, a 3. And of course, it simply exits the script. In this video, we learned how to use just the while and until looping constructs. We'll start by taking a look at the while looping construct. When we have a loop, it means that we want to execute a series of commands over and over. But often, we only want to do that until a certain condition is met. With a while loop, we have a condition we're testing at the top. The condition here is within square brackets. We are testing the menu choice variable. In our specific case, the menu choice variable gets populated when the user presses a number that corresponds to the menu system in this script. Our while loop is testing the menu choice variable, and specifically we're testing while it is not equal to 3. So while that variable is not equal to 3, we are doing all of these commands, we're executing all of the commands, all the way down to where the word done exists. Then we come back up and we do it all again as long as the menu choice variable is not equal to 3. Now, let's take a look at how that behaves from the command line. So this script is called menu.sh. Back here at the command line, I'm going to run that script. So I'll type /menu.sh and I'll press enter. It's waiting for me to enter my choice from our 3-choice menu. I'll go ahead and test number 1, which should list logged in users. Okay, that works correctly, then I'll press enter. Number 2 should list the Linux kernel version, that's working. And finally, number 3 exits. So if we take a look back at our script, we can see that we are testing in our while loop the menu choice variable. And when it does equal 3, the loop stops. Let's look at another file called menu2.sh, which is very similar. Instead of using a while loop, though, it's using an until loop. The until loop tests the condition at the top, and like a while loop, it too uses a do-done construct. The commands we want to execute within the loop exist between do and done. However, here we're testing the variable menu choice to see if it equals a value of 3, which means the user has pressed 3 for exit. They want to get out of the script. So you might wonder, well, what exactly is the difference then between using a while versus an until loop? And the difference is this. With a while loop, the code executes if the condition is true. With an until loop, the code executes if the condition is false. And therein lies the only difference. Other than that, does it really matter whether we use a while loop or an until loop? Well, as long as you construct your condition carefully, no, it really doesn't matter. Let's go back to the command line and let's run menu2.sh to make sure it runs correctly. So back here at the command prompt, I'll type /menu2.sh. And I'll press number 1 to see if that works. It looks correct. I'll press number 2, which should list the Linux kernel version. That looks correct. And I'll press 3, which takes me out of the script. So functionally, there really is no difference between using while and until, and at least in terms of the end result. In this video, we learned how to use the while and until looping constructs. In this video, I'll demonstrate how to use the test command. In Linux, the test command is used to test expressions or conditions, as well as attributes related to files. At the command prompt in Linux, I'll type man --test so that we can look at the manual page for the test command. As we scroll down through the description of the command, we can see it tells us that we can look for expressions that are true or false. And as we go further down through the man page, we see some command line switches that check things like whether a file is a directory, that would be -d, or -e, whether a file exists, -f, whether a file exists and is a regular file, and so on. I'll type Q to quit, and at the command line, we'll begin by typing test --10 -gt, that stands for greater than, 5 $echo, and in quotes I'll put in the word true. The $& means that as long as the item on the left and right are both true, then the one on the right will execute. So it should say true on the screen if 10 is greater than 5. Of course, 10 is greater than 5, so it echoes true to the screen. But I'll use the up arrow key and I'll change the condition so that it tests whether 10 is greater than 55. And when I press enter, we get nothing returned to the screen because that is not true. We can also use the test command in conjunction with files and directories. I'll type clear to clear the screen, then I'll type ls. For example, notice the presence of a file here called user activity. If I want to test the existence as to whether that file is there or not, I could use the test command with the -e switch. So I'll type test -e, and I'll type in the name of the file, user activity. Now when I press enter, I don't get anything returned, but I'm going to type echo $?? This will return the exit status of the last command, and 0 means true. Anything greater than 0 would mean false. For example, if I were to test for the existence of a file that I know is not here called useractivity2, when I echo the exit status of the last command, it's a value greater than 0, which means not successful. It returned a 1 in this case. We can also work with the test command within a script. Let's take a look at an existing script here called filetester.sh. It displays a menu to the end user where the user can test file existence or write access. So if they press number 1, which is for testing file existence, then down below we are reading in a file name variable. We're asking the user to enter the file name. And then we have an if statement where we are testing the existence of the file. But notice in this example, we're using square brackets to contain our condition instead of using the word test. You can use either one. Here, -e is being used to test for the existence of the user-supplied file name. If we go further down, we can see that we can also use the test keyword. In our second example, where we are testing write access to a file, we're actually using the test command with the -w switch. So you could use either the square brackets or the test command. But remember, when you use the square brackets for your condition, you need a space after the opening square bracket and a space before the closing square bracket. Let's go ahead and test this filetester.sh script. Back at the command line, I'm going to type /filetester.sh and I'll press enter. The first thing I'm going to do is test menu option 1 to test file existence. So I'll press 1. It wants me to enter a file name, so maybe I'll put in user activity because we know that's there. And it tells me that that file does exist. Now I'll try menu option 2 to test file write access. And maybe I'll test the same file name. Is it writable or is it not for the current user? And it says it is writable. And finally, I'll press 3 to exit our script. In Linux, when issuing commands, we can use expansion. With expansion, when we type something in, it gets expanded into something different before the shell performs an action against the command. For example, if I were to type echo space, open double quote, hello world, close double quote, it would echo back the string hello world to the screen. Yet, if I type echo space asterisk and press enter, instead of echoing the asterisk back to the screen, the shell expands that, and it assumes that I'm echoing back a list of all of the files in the current subdirectory. With the echo command, we can also work with numeric values in ranges. For example, I'll type echo space open curly brace 6.8 close curly brace. When I press enter, it gives me a numeric sequence beginning with 6 through to and including the number 8. So it didn't echo that back literally. For that to happen, I would have to have enclosed it within double quotes, which I will do. Now it literally returns open curly brace 6.8 closing curly brace. We can also use the echo command with arithmetic. Essentially, we can use the shell as a calculator. What we would do is type echo space $, and after the $, we would then type in 2 opening parentheses, and then we would put in our arithmetic. Let's say 567 multiplied by 89, close double parentheses. When I press enter, it does the math and returns the answer. Shell expansion also takes the form of special symbols that have meaning. For example, the tilde. If I type cd space tilde and press enter, when I type pwd to print the working directory, I see that it's placed me, user root, into my home directory. So the tilde gets expanded to the current user's home directory. Also, if I were to type ls space capital DOC and then press the tab key on the keyboard, the shell will expand out the rest of that file, or in this case, directory name. There are other interesting aspects of shell expansion. One is how we take the results of a Linux command and store it in a variable. Consider the fact that I want to make a variable called current date. And what I'd like to store in that is the current date, which I can retrieve in Linux with the date command. So I'm going to type in current date equals date. Now I'm going to type echo $ current date. However, it doesn't return today's date. Instead, it literally returns the word date. What I want to happen here is I want the shell to expand date into the Linux date command. For that to happen, I'd have to do the following. I would type in current date equals $ open parentheses, then my Linux command or commands, followed by a closing parentheses. So I've enclosed my Linux command in a $ and then a set of parentheses. I'll press enter and I'll echo back my current date variable, and we can see now that it returns the date and time. So it worked the way we wanted it to originally. We can also do the same type of expansion within a script. Let's take a look at the sample script here. It's called yearly_dirs.sh. It's used to create yearly subdirectories with the user-specified directory name suffix. So here, it's going to ask the user to enter a directory name suffix, and we're reading it into a variable called dir_suffix. Then the script is using the makedir command to make a series of subdirectories beginning with 20 followed by 09. So that means it'll make a subdirectory called 2009. It'll make a subdirectory called 2010, 2011, all the way up to 2015. That's because the 09 through to the 15 are each separated by commas and they're contained within a set of curly brackets. So the shell will expand that. Then we are adding our directory suffix that we asked the user for as the tail end of the subdirectory name. Let's go ahead and run this script to see if it actually works. So I'm going to change into the /user_file/scripts directory. This is where we can see we've got our yearly dirs shell script. I want to run it, so I'll type / and I'll type in year and press tab. Of course, the shell will expand that for the full file name. I'll press enter. Here it's asking me to enter a directory name suffix. Here I'm going to type invoices and I'm going to press enter. It tells me that it created subdirectories starting at 2009_invoices all the way up to and including 2015_invoices. Let's just type ls to make sure that's true. In fact, it did. I'm going to invoke the script again, and this time as a directory name suffix, I'll put in something different. Let's say archive. And according to the script, it created those subdirectories, and I can verify that again with ls. So the purpose of shell expansion, whether at the command line or in the script, is to save time or to perform specific types of calculations. In this video, we learned how to use expansion in scripts. I'll discuss how to use the exit status. At the Linux command line, the exit status lets us determine whether the previously executed command completed successfully or not. We can look at the exit status via testing a variable. I'm going to type echo space $?. So question mark is a built-in shell variable, and it returns the status of the last executed command. Here it's returned a value of 0, and this is a good thing because 0 means true. The last command that executed completed successfully. But if we return a value that is greater than 0, it means false. The last command that ran did not complete successfully. Now we can play on this either at the command line or within a shell script. Let's start at the command line. I'm going to type 2 opening square brackets followed by a space, then 10, space dash GT for greater than, space 5, space closing double square brackets. So really I'm just testing, is 10 greater than 5? I'm going to go ahead and press enter. Now it doesn't return anything to the screen, and nor should it. What we would do at this point is test the built-in question mark variable. So I'm going to type echo space $? And we can see it's returned a value of 10, which means true. That's because 10 is greater than 5. If I were to go back to our little condition and maybe change it to 10 greater than 65 and press enter, again, nothing happens on the screen, and it shouldn't. But if we take a look at the built-in shell variable for the exit status, this time it returned a value of 1. So remember, an exit status that's greater than 0 is bad news. It means false. The previous command did not evaluate to being true. Now we can also use this to our advantage in shell scripts. Let's go take a look at some examples. Here's a script called callingscript.sh that calls a second script, which is called calledscript.sh. In the calling script, all it's doing is invoking a second script. But let's go into the second script and take a peek at what it's doing. What it's trying to do is it's trying to change directory to a non-existent directory. After which, we have an if statement where we are testing the built-in shell variable for the exit status. So that would be $? And we're testing whether or not it equals 0. Well, if the built-in shell variable for the exit status does equal 0, it's going to echo back no problem to the screen. Otherwise, it's going to return Houston, we have a problem. Let's run the calling script, which in turn will call the second script to see what the behavior is in the shell. Because I'm in the same subdirectory with the scripts, I can invoke the calling script by typing // and calling script.sh. I'm going to go ahead and press enter. Here we can see some returned text that says this is the calling script, this is the called script. Then we have a couple of error messages, and of course it returns Houston, we have a problem. So that's because even here at the shell, if we type in echo $, we have 0 because the script completed, but while the script was running within it, we had a failure. So we can test our built-in shell variable for exit status within the script to see if there's a problem or not.